Okay, hi everyone. Um, I thought I'd do another little video of the kind of like the next stage in the procedure, if you like. The first stage from the first video was using EDA web-based PCB design package, and I didn't go through the whole process. Obviously, I just went through the quickly went through the sort of process of going from the schematic to the PCB, and then how to place a few components, and then ultimately export the Gerber files. Gerber files being the sort of industry standard description or file description for PCBs. But Easy EDA is a PCB design package. It is not designed for creating CNC tooling paths. The normal route would be you take the Gerber files and then you would have the PCB manufactured from them. Any PCB manufacturer will take Gerber files and send you PCBs back. But I'm not using that route. I'm going to use my CNC machine to mill the board, mill isolation. So another step is required, and that requires another piece of software. So and the piece of software I've sort of settled on, having tried lots of different software, is called FlatCAM, which is free, which is fantastic because it's a really nice bit of software, and it's very easy to use. It's really intuitive. I really like the workflow, and most importantly, it actually works, which is always a good thing. So yeah, so what effectively, and I'm not going to go through that, a bit like Easy EDA, I'm not intending to go through every single step because it's very well documented, and there's tons of other YouTube videos that go through how to use FlatCAM. I was just going to use this video to illustrate the post-processing steps I needed to do for this particular design, and why they were necessary. There were a couple of things that needed to be done, and this just illustrates them. So let's not, I won't withdraw on anymore. The first thing you do is open your your Gerber file. So there's a whole bunch of stuff here you can open, one of which is Open Gerber. So these are all the Gerber files, .g files that were exported from Easy EDA. The only one that's particularly actually relevant here is the GTL, or the Gerber top level file. So we open that. And as soon as that happened, I thought, well, that was a good sign, because the board looks right. The Gerber file's been correctly interpreted. It looks nice. Just kind of let you sort of think, yeah, if I can achieve that, then happy days. So there were a couple of little things that I needed to do. I'm not the fault of any one particular software. It's probably just the workflow. So what happens is with FlatCAM is once you've got your Gerber file like this, there's various steps you have to go through. It's not just one step, which initially you think, oh, that doesn't sound good. But when you've been through the steps, you realise that's one of the powers of the tool, is that each step gives you a lot of design flexibility over what's going to happen next. And it's quite intuitive. It's not once you've just watched a quick tutorial, you say, oh yeah, okay, so you start with a Gerber file. For this top level, from the Gerber file we generate a geometry, which is effectively the paths that are going to be milled. Then from that geometry, the next stage is to generate tooling paths, and then from the tooling paths, the last stage is to actually generate the G code, which is going to be used by my CNC controller to actually perform the milling, which is just effectively X, Y, Z, go here, go there, go up, go down. So we click on. So the idea is you click on that, you go to the Gerber file, goes selected. This was all these tool diameters and stuff, 0.5 millimeter, all these parameters you can set up under the options. You go to options, you can set them up for the application, or you can set them up for the project. So let's just generate the geometry. Right, there we go. Now the first problem I encountered when this happened is to do with the holes. The geometry for the actual board, for the most part, is perfectly good. It was the holes that were a problem. Now, for some reason, and maybe you can do this, I actually banged a question off to the guys at Easy EDA, and I couldn't find a solution. Whenever I drop a hole or I drop a pad in Easy EDA, and then I do the copper pour, it always generates copper pore relief, which is kind of understandable. If you're going to drop a hole through your copper, you'd expect the PCB design tool to put isolation relief around it. So if you put a bolt through, you don't short the bolt to the copper. So that's kind of standard practice. But in my particular case, for this design, that's not what I wanted. I don't want any relief around the hole. I just want a hole straight through the copper, straight through the fiberglass, straight through the copper on the other side with no relief, because I want to drop a Vero pin through and connect the two together, which would normally be the job of a via. So if you were having this commercially made, you drop vias in, not holes. The vias would then connect. They'd be through hole plated from the top to the bottom, but I'm going to drop a Vero pin through, so it's kind of like, that's where the confusion's crept in. So, but there's a way around it, because FlatCAM has generated all this geometry, but it also gives you a really cool and easy to use geometry editor, which I'll now sort of demonstrate. So once you've generated geometry, you get a _ISO file. Now it's the ISO file that you now want to edit, not the original file. It's the ISO file which contains the geometry. So you select that, go to selected, and you can go to edit geometry, and it all goes slightly darker to show that it's like in edit mode. Now the only problem here is if you click on that hole there, see, it's not just the hole that lights up. If I click off the hole, click on this hole, see, it's other parts of the geometry also light up, which means it's grouped. So if I hit delete now, I'm going to not only delete the whole geometry, I'm going to delete all the rest of the geometry associated with it. So what I need to do is cut the path. So cut the hole from the rest of the geometry. And there's a button up here, so we'll cut path. So I've highlighted this hole, and it's highlighted a whole bunch of other stuff. So hit cut path. It does exactly what it says on the tin. Cuts the path. Now if I click on the hole, only the hole lights up. So now all these other holes on the top here are also part of the same path, so they've all been disconnected as well. So just quickly check. See, that one's got a whole bunch of stuff associated with it as well. So we'll cut that path. Try this one. That one's isolated. That one's isolated. That's associated with a bunch of other stuff, including 2 more holes. Cut that path. That's isolated. That's isolated. So is that one. So now we've got the hole. So we just delete it. Delete the geometry. Right? Deleting the geometry around the hole, which will be a lot bit more apparent in a second. Bear with me. So just go around all these 10 holes, deleting their associated geometry. And this is quite powerful. I mean, I know it looks simple. I think, well, you know, it's no big shapes, just deleting stuff, but being able to break the paths and delete the whole geometry like this is. So I've done all that, and then you up to edit, and then update geometry, and then there you go. So we've got all the geometry that was there before, but now we've lost the geometry for the holes. So that means that ultimately when we generate the tooling paths, there won't be any tooling paths for those holes. So this ultimately means that the board will get milled, the holes will just stay as copper because we've deleted the geometry, but I've still got the drill file from Easy EDA, so I can drill straight through those hole centers with no isolation, if that makes sense. Now, the only other thing with this, and I put a couple of pictures up on the Instructable, which showed the difference between the first board I milled and then the second board I milled. The first board I milled, because you're using a milling tool, you know, it's a 0.5mm. Unfortunately, even though I tried as hard as I could, there were a couple of little areas where there were little niggly bits of copper left over that I didn't really want. One was here. There were some little copper strands in between the transistors, and there was a little bit kind of here. They wouldn't have made any difference. They wouldn't have affected the functionality. Just they were a bit annoying. So what you can do is you can go to edit. Again, edit geometry. And there's a whole bunch of stuff. You can add polygons and circles. And one of the things you can add is add just a path. So I can click here, here, and then release. And then what I'm doing is adding in geometry on top of the automated geometry. So it's just a quick example. So for example, in between this transistor I had some unfortunate little filaments. So that this geometry I've added in here is going to result in a tooling path, which means that the milling tool is going to mill out that unfortunate little bit of copper that's not required, and the same here and elsewhere. So once you've done that, again you go edit, update geometry. And now they're part of the geometry. Right, zoom it out. Now the next thing that was I needed to have a little post-process fiddle with was the CNC, the hole drilling file. It's again easier to just demonstrate. So if I open up, you don't. It's not a Gerber file. It's an Exelon file. I have trouble pronouncing that. An Exelon file, which is this npth.drill file here, which is also exported from Easy EDA. Now if I open that up, now that was quite subtle, and it appears nothing's really happened. It did happen. It just did it wrong. So if I zoom in a bit here, you can see these little red dots have appeared. I'll open that. Now those red dots are the drill centers. Now it's quite obvious that they're in the wrong place. They're in the right place relative to each other, but they're in the wrong absolute place, and that's because the scaling's wrong. And now I think what's happened. What's happened is even though I told Easy EDA to use millimeters, it's exported. I don't quite know why. It might have been pilot error, but it's exported the drill file in inches, and I've told FlatCAM that I want to use millimeters, and FlatCAM's used millimeters, so it's taken an inches file thinking it's millimeters, so everything's out by a factor of 2.54, i.e. 2.54 centimeters to the inch. Now we can get round that if you go to the project file and hit on the drill file selected. There's luckily a scaling factor down here. So if I type, it was set to 1 or unity. If I set that to 2.54 and scale, voila. Now you can see those little red dots have all jumped to the centers of the holes. Not that there's going to be any holes, because remember we've moved the geometry. But the tool, when I generate the tooling paths for the CNC machine, it will generate now tooling paths with hole centers that correspond to where I want holes, as opposed to them all being in the corner. It would have been a disaster. So yeah, that's so I don't quite know why there's a discrepancy between inches and millimeters. I was expecting Easy EDA to use millimeters throughout, and for some reason it has done, apart from the drilling file. So other than that, everything else went smoothly. So from that you then, well, I won't go through all the rest of the steps, but you basically have now got, you can now generate the next, all the other steps, and then ultimately create a whole series of you end up with 3 G-code files. You end up with a G-code file for doing the actual relief, the PCB itself, what you're trying to achieve, the relief milling. You end up with another G-code file which does the holes, tells the machine where to drill the holes, and then you end up with a third one which is used for doing the board cut outline, for cutting the outline. So you can do an outline cut. But if I click back on here, select it, and then do board outline, see it's drawn another piece of geometry around the board, and that ultimately is used for creating a tooling path for cutting your board out. And you see it's left little gaps here on the sides, on the top and the bottom. So you can preset that gap size here. So when it mills out the board, instead of the board kind of like dropping out right at the very end and potentially cracking or splitting, it'll leave a little snap out tab of 0.15 millimeters on the face. So you end up with the board still in its, milled out but still in place, and then all you do is just snap it out, which is kind of cool. So yeah, I don't think there's much else to say about FlatCAM. I say that wasn't a comprehensive run through, but I say it's if if you go online and look at the various videos, it's all reasonably straightforward. Those were just the main post-processing steps I had to apply in order to achieve what I wanted to achieve. Anyway, thanks for watching. Cheers.